Have you ever wondered what exactly happens after you click a link or type an address into your browser, seeing that web page magically appear on your screen? It feels instantaneous, but behind the scenes, a complex dance of digital communication ensures that information travels seamlessly from servers across the globe right to your device. Web servers send Hypertext Transfer Protocol, or HTTP, responses by assembling data into a structured message, applying a status code to indicate the outcome of the request, and then transmitting this message back to the client using the underlying Transmission Control Protocol/Internet Protocol, or TCP/IP, network stack. The core mechanism hinges on the client-server model, where your browser acts as the client making a request, and the web server processes that request to provide a suitable response. This interaction is stateless, meaning each request and response pair is handled independently, although sessions can be managed through mechanisms like cookies. When a server receives an HTTP request, it performs several steps. It first parses the request to understand what resource the client is asking for, such as an HTML file, an image, or data from an application programming interface, also known as an API. Then, it retrieves or dynamically generates the requested content. Finally, it packages this content into an HTTP response message. To understand this process, think of it as preparing a carefully labeled package for delivery. The server first decides on an HTTP status code, like 204 OK, 400 and for 4 not found, or 504 internal server error. This code tells your browser the request's outcome. Next, it adds HTTP headers, which are like postage labels providing metadata about the response. These headers might specify the content type, like text/HTML, or instruct your browser on caching behavior, or even set cookies. Finally, the actual content, whether it is a web page, an image, or data, is attached as the message body. This entire package is then handed down to the TCP layer for reliable transmission across the internet. A fascinating insight into this process is how content delivery networks, or CDNs, optimize response times. When you request a resource, a CDN might serve a cached copy from a server geographically closer to you, dramatically reducing latency. This is often indicated by specific HTTP headers in the response, such as Xcache or server, which your browser or network tools can inspect. Additionally, understanding the different HTTP methods, like GET for retrieving information and POST for sending data, highlights the server's role in fulfilling various types of client interactions and preparing appropriate responses. Ultimately, the efficient and reliable sending of HTTP responses is the bedrock of your entire web experience, ensuring that every click, every search, and every loaded page is delivered accurately and promptly. By carefully structuring messages with status codes, headers, and content, web servers transform your requests into the rich, interactive digital world you navigate daily.
If you love understanding how the web works, like, subscribe, and stay connected with us.